Went to the today's class on OSI model, which is also known as the Open Systems Interconnection Model. In this today's session, we'll understand what the OSI model is, why it was developed, and discuss each of its 7 layers in detail along with their functions. So, these are the contents that we are going to see today. OSI model is a conceptual framework that standardizes how different computer systems communicate over a network. It was developed by the International Organization for Standardization in the year 1984 to provide universal set of rules for network communication. This model divides the process of data communication into 7 layers where each layer performs a specific functionality and interacts with the layer that is below and above it. So the OSI model was developed to solve communication issues between different networking systems and manufacturers. Before the OSI model, every company has its own way of building the network protocols. So the devices from different vendors often couldn't communicate. The OSI model helped bring standardization, allowing open communication between the heterogeneous systems and promoting interoperability and modularity. It is a 7-layer architecture. The OSI model is a 7-layer architecture where each layer performs specific functionality. All these 7 layers work collaboratively to transmit the data from one layer to the other. So these are the 7 layers in the architectural diagram of the OSI model. So the first layer is a physical layer, data link layer and network layer. These 3 layers are hardware layers. Then the transport layer is called the heart of OSI, and the remaining layers like session, presentation and application layers are software layers. So the lower set of layers handle hardware and routing while the upper deals with software and user interaction. The first layer, that is called physical layer. Physical layer is the lowest layer of OSI model. It deals with the physical connection between the devices like cables, switches, voltages and network interface cards. It defines how bits like zeros and ones are transmitted over the physical media like copper wire, fiber optics or radio waves. The functionality of physical layer are as follows. The first thing is bit synchronization, bit rate control, physical topologies and transmission mode. So the second layer is a data link layer. The data link layer ensures the reliable transfer of data across the physical link between the two devices. It breaks data into frames, performs error detection and correction, and handles MAC addressing for identifying devices on the same network. This layer is divided into 2 sub-layers. One is logical link control and media access control. The former manages error checking and frame synchronization, and the latter controls how devices access the physical medium. The functions of the data link layer are flow control and access control. The third layer is network layer. The network layer is responsible for logical addressing and routing of data packets across multiple networks. It determines the best path for data to reach its destination and handles packet forwarding and congestion control. Common protocols here used in this network layers include Internet Protocol, ICMP and IGMP. Devices such as routers operate at this layer. So the functions of the network layer are routing and logical addressing. The network protocol determines which route is suitable from source to destination. This process is called routing. So in order to identify each device on internet uniquely, each network layer defines an addressing scheme. So the senders and receivers IP address are placed in the header by the network layer. The fourth layer is transport layer. Transport layer provides end-to-end communication between the two devices. It ensures data is delivered reliably, in order and without any error. It also handles segmentation, error control, and flow control. The protocols used in this layer are TCP, that is Transmission Control Protocol, which is reliable and connection oriented. And the next protocol is UDP, it is User Datagram Protocol, which is faster but connectionless. The functions of the transport layer are as follows: segmentation and reassembly, service point addressing. The fifth layer is session layer. This session layer establishes, manages and terminates session between the applications on different systems. It is responsible for setting up, maintaining and synchronizing the interaction between the communicating systems. For example, when you log into a remote server, a session is created. If interrupted, the session layer helps recover and resume communication. So the sixth layer, which is called presentation layer. So this layer is also called as the translation layer. It translates data between the application layer and the network format. It is responsible for data encryption, compression and format conversion. So examples are converting the text to ASCII or encrypting information using SSL or TLS before transmission. Those are the functions here. As I already said, it's translation and encryption and decryption, compression. So data encapsulation. So the OSI model is theoretical model, while the TCP/IP model is practical implementation that is used on the internet. The OSI model has 7 layers, whereas the TCP has 4: application, transport, internet, network access. So despite the differences, both servers serve the same purpose, enabling reliable communication over network. So this is the summary of the OSI layers. So to summarize, the OSI model breaks a complex process of data communication into several simple layers. Each layer serves a unique purpose and interacts only with its adjacent layers, making troubleshooting and protocol design easier. So we can use a mnemonic to remember this. All people seem to need data processing. So that is for application, presentation, session, transport, network, data link and physical layers. So the OSI model remains as one of the most important concepts in networking. It helps network engineers and students understand how data travels from one device to another across a network. I hope this session helped you gain a clear understanding of the 7 layers of the OSI model and their purpose. Thank you for watching.